Greetings, Geographer Joseph Kursky here with you, exploring the world as it could look at night with ArcGIS Online. So if you go to www.arcgis.com and search for Earth at Night, you'll see this 2D map. You can see the east coast of Australia and how different it looks from the central and the west coast in terms of lights at night, which have to do with population and population density and a few other factors that we'll talk about here. Take a look at the Ganges versus just north of the Himalayas, and you'll see the difference in, again, simulated lights at night, but actually the data being mapped is population density. You can see the Nile Delta starkly contrasted with the surrounding deserts of northeastern Africa. Look at southern Africa, the deserts of southwest Africa. Some of these lights at night are actually not strictly from population density. Some of them are actually from offshore oil drilling. So you can see some energy development happening, for example, in western North Dakota, as you can see on that prior view right there, and I'm panning up to it. Look at the central U.S., though. Look at the regularly spaced grid pattern of roads reflecting in population density. And again, lights at night or Earth at night in ArcGIS Online, scanning up to Hudson Bay, Nunavut in Canada. Just fascinating to be able to do this in 2D. But the 3D scene, which is another part of ArcGIS Online, and you have access to this in your web browser, no software install required. You can go ahead and do what I'm doing here and look at the Hawaiian Islands, for example, and you can tilt and rotate. Now, why does the Earth at night disappear? Because most map layers are produced and published at specific scales. And this particular Earth at night one, and you can do a search for different cities and landforms as I'm doing here in the upper right. Certain layers are published at certain scales. So the Earth at night is meant to be a regional or a national layer. It's not meant to be viewed at a high resolution simply because of the way that the data were rendered and produced. But being able to do this in a 3D scene as you have here, which is part of the ArcGIS Online platform. Look at the difference between Haiti and Puerto Rico. Lots of factors, and you can use this if you're an instructor. You can use this to teach about economic inequalities and differences around the world, coastal cities versus interior cities, and the vulnerability of those coastal cities to certain natural hazards, for example, tsunamis, looking at different population density around the world. So this is, I think, an amazing tool, not only for Earth at night and looking at development and cities and settlement historically and currently. Take a look at the UAE, and those fishing villages of the 1970s are now major cities. And look at the influence of terrain, for example, the Swiss Alps, and how few people actually live on those steep slopes, understandably. And then pan across, we've got Iran, Pakistan, North India here, Bangladesh, and then Southeast Asia. But being able to look at this in multiple scales and looking at the influence of, and now look at this, South Korea versus North Korea, stark contrast there. So you can talk about the reasons why, the whys of where. That's why we use these mapping tools, to explore our world and to find out why things are where they are. What's where, why is it there, and why should we care? So in other words, you can use these tools to get students interested in different issues around the world. Another nice thing about these tools is, as you can see, you can rotate them so that north is not always at the top to give a different perspective. And you can also, as I'm doing here in the upper right, you can simulate daylight and darkness for different times of day and also different times of the year. So you can even teach about climate and also the Earth's rotation and revolution around the sun with these tools. Fascinating to be able to do that, looking at the difference between, for example, the Arctic in the December time period versus the Antarctic in the December time period, or in June at the summer solstice in the northern hemisphere and the winter solstice in the southern hemisphere. So fascinating to be able to do this with these tools at your fingertips. Again, it's the 3D scene viewer. We started the video with a 2D map in ArcGIS Online. Notice that you can change the base map, as I do in other videos as well, but you can change the base map. So now we're looking at the imagery base, and again, simulating daily and seasonal variation in the sun and the sun angle. Now we're taking a look, we're going deep into the northern Italy, Austria, Switzerland area, and you can see the different resolutions that are available thanks to the wonders of geographic information systems. Having these tools available at your fingertips with these data sets is really a remarkable teaching and research tool. And they're also fascinating to just the general public. If you're not an educator and not a student and you just love looking at the planet, which I encourage people to do, go ahead and use these tools, 2D and 3D maps inside ArcGIS Online. Notice that you can type in cities, mountains, other things. So I'm going to look at Eastbourne, England, and we're going to take a look at the Chalk Cliffs, one of my favorite landscapes in the world. And you can also teach about changes on the Earth's surface based on human impact, urbanization, deforestation, and also reforestation, but also looking at coastal erosion, as a result of various factors. You can look at glacial advance and retreat and construction of reservoirs, much more with these tools at your fingertips. You can also save these maps and scenes and make multimedia maps from them. For example, story maps, which I devote many other videos to talking about. So these maps can be saved, they can be shared, they can be collaboratively worked on, they can be modified. You can add different layers to these maps and save them in your own ArcGIS Online account, and you can get a free account on developers.arcgis.com, for example. There are lots of tutorials that my organization ESRI produces to get into more detail in terms of how to build and create these 3D scenes, but basically if you start with ArcGIS Online and go to map and then go to scene, you'll be doing what I'm doing here. I'm not going anything beyond the basics in this particular video. But here's another one of my favorite landscapes, the 12 Apostles Rocks off of Victoria, Australia. Good on you, mate. She'll be right. Now we're going to take a look at Mount St. Helens, Washington, one of the amazing volcanic landscapes on our planet here. And notice how if you type in a name that you don't actually have to zoom and pan yourself. The system actually does that for you. And so now we're going to go to Mount St. Helens and look at the blast from 1980 and subsequent eruptions. We're going to look at the land use and the land cover, which is, as you may know, heavily forested. It's in a national forest, but the area around the volcano is, of course, subject to frequent landslides and ash, and so the trees have a difficult time growing there, although a lot of the trees from the 1980 eruption, which was the most major eruption in our time, have grown back. And these aren't just small trees. These are Pacific Northwest mid-latitude rainforest trees, so they're quite large and they're already growing through the ash. Fascinating to look at this in terms of satellite imagery. Wow. So we started with the Earth at night, and now we're looking at satellite imagery from a variety of different sources: USGS, US Forest Service, Digital Globe, now Maxar, and other sources that my organization, ESRI, actually obtains the data from and puts it in these wonderful tools that you have at your fingertips. Look at the inside of the crater there. Now imagine Agassiz, von Humboldt, and other explorers and scientists of the past, Shackleton and others, having this at their fingertips. They just would have gone crazy. Oh my goodness, they would have said, look at this. This is amazing to be able to analyze our planet. So you and I are definitely reaping the benefits of these mapping technologies, which actually didn't just appear last year. They've been evolving for hundreds of years. And I would even argue over thousands of years, since the Babylonian clay tablets and Idrisi's map of 1100 on silver and many other mapping and innovations over the years, satellite technology, GPS, remote sensing, and so on. Lake San Cristobal in Colorado showing the Slumgullion slow-moving landslide, which has dammed up the river here into this beautiful lake. Actually, it's quite a beautiful place to go fishing, camping, and hiking around. But again, natural features on the landscape, natural processes, and you can also look at human processes as well, as I mentioned a few moments ago. Now, in the U.S., you also have the capability of adding the USGS topo maps to these 2D and 3D maps. So that's another wonderful layer, and depending on where you are on the planet, you might have access to other data. If the data is not part of this base map, well, then there are other videos that my organization has produced explaining how to add your own data to these maps. So again, lots of flexibility here for exploration, research, discovery, teaching, and more. But I just love being able to use these USGS topo maps. Let's look at one more of my favorite landforms, which is also in the many books on geomorphology, and that is the Ennis, Montana alluvial fan. This is the classic example of an alluvial fan. You can see this beautiful fan shape as evidenced in the contour lines, and we're also going to look at the satellite image as well. Ennis, Montana, the alluvial fan there is off to the southwest, you'll see here. And you can see the, oh, look at that. It's the Cedar Creek alluvial fan near Ennis, actually. And look at those contours. Oh, it's just, it's the perfect fan shape. It's just amazing. It makes you want to go there on foot, doesn't it? That's what I'm hoping some of these mapping oh, now I'm changing the resolution here. So go out there, get into the field if possible. That's the subject of many of my videos on this channel. Let's change it to imagery now and take a look at the alluvial fan. In this case, the topo map actually gives you a better impression of the elevation than the imagery does, but it's just interesting to look at the imagery and compare it to the topographic map. Changing the base map to terrain with labels now. Now I'm actually going to log into ArcGIS Online so that I can add layers. That's one of the things that you can do when you log in or sign in to an ArcGIS Online account, either from your university or a free one that I mentioned earlier, or one your business or your government agency actually has. Then you can add data. You can do lots of other things like spatial analysis as well. And I'm going to add one of my favorite mapping layers, the ESRI Hydro Reference Overlay. So you get scalable rivers, ponds, lakes, and coastlines, as you can see here, but you also, in certain parts of the world, you actually get these brown dotted lines. You'll probably be able to tell what these are, and these are the watershed boundaries. So if we look at, for example, this lake that I'm zooming in on right now, you can see that this lake, Cedar Lake, which of course the Cedar Creek drains from, you can see this beautiful watershed boundary. So if you're teaching about, again, geomorphology, landform studies, and students have a hard time sometimes visualizing on a 2D map, well, then this 3D scene with these ridges popped up like they are, and you can, of course, exaggerate these as you see fit, but it's a great way of teaching about watersheds, landforms, river systems, and river geomorphology. As I zoom out and change the scale from a large scale to a smaller scale, as we see here, you'll only see the major rivers. So that's another nice thing about the rivers layer and many of the other mapping features, is that they're scalable. Now, in the older clunky days of geographic information systems, it was very difficult to overlay data and actually even obtain the data in the first place. But having all this at your fingertips, much of which comes from the Living Atlas of the World, and I have other videos on the Living Atlas of the World, and so do my colleagues. But the Living Atlas of the World contains 8,500-ish data layers, including this one here, which is the ESRI Hydro Reference Overlay, which, again, as I zoom out, I only see now in North America. And now let's look at South America. I'm only seeing the major rivers, so I can really get a good sense of, wow, look at how many rivers drain into the Amazon in Brazil and in certain other surrounding countries. Let's take a look at the Nile and how few rivers comparably drain into the Nile, owing in part to the dry, arid conditions. There's not a lot of rainfall. There's not a lot of rivers draining into the Nile, but the Nile coming all the way from the equatorial regions. Taking a look at other major rivers of the world, the Ganges, the Yangtze, and others. I love this area right here that I'm pointing the mouse on right now. This is a place in southwest China where three major rivers are very close in proximity, but they actually drain into vastly different seas and oceans, and in part because of the topography there. Okay. Thanks, folks, for being with me. That is the 2D and 3D ArcGIS Online web mapping tools at your fingertips, and also a couple of my favorite data layers that I think are incredibly useful for instruction, research, and more. And that is the Earth at Night, and also the satellite imagery, and also the U.S. topographic maps. And we also looked at the ESRI World Hydro. Thanks for being with me. Get out there and explore in the field, but also use these mapping tools. Thanks.